Hello everyone, welcome to this channel. Today we will see the first chapter of discrete mathematics and graph theory, which is given by the course for computer science, IT, information system, mathematics, and computer engineering students. It's important for those students. So the first chapter, which is the first topic, is about counting principle. Under this chapter, we'll see different concepts, and we will start with the counting principle. There are two counting principles: addition and multiplication principle, or sum and product rule principles, and then we'll see about the permutation and combination, and what are the relations between computation, combination, and permutation, and how can we define the permutation of objects and the permutation of a combination of objects. And then we'll see about the inclusion-exclusion principle using set theory concepts, and then we'll see about Piganol's principles also. And finally, on this chapter, we'll see about binomial expansion. So under this section, counting principle, there are two, as I have said it before, there are two concepts: addition rule and multiplication rule. So addition rule, or we call it sum rule, and we can define this rule as suppose that the first event occur in n ways, and the other second event occur in m ways, and assumes that the two events are mutually exclusive events, or they do not occur simultaneously. Mutually exclusive means that when the events are not occurring at the same time or simultaneously, then that events are said to be mutually exclusive. Then the occurrence of either of the two events is given by m plus n ways. M plus n ways. So first of all, an event is an outcome of a given experiment. An outcome of a given experiment is said to be an event. So it seems that there is an experiment. So the first event occurs in m ways, and the other event occurs in n ways. Then and assuming that the two events do not occur simultaneously, then the occurrence of the first event or the second event is m plus n ways. So when we see with an example, suppose there are 6 male and 4 female calculus teachers teaching. In how many ways can the student choose a calculus 2 class? So clearly, female and male are mutually exclusive events. They do not occur simultaneously. So using that, a student can choose a class in either of 6 plus 4 ways. 6 plus 4 ways. Either of the 4 females or either of the 6 females. So the occurrence of the female and or male is 6 plus 10, which is 10 ways. The other interesting example is suppose event E is an event occurring of choosing prime numbers between 10 to 20, and suppose F is an event of choosing an even number between 10 to 20. Then find in how many ways can event F and E occur. So clearly, we can suppose that E is choosing a prime number between 10 to 20. Prime number is a number which has one factor only itself, and an even number is a number which is divided by 2. And when we take those numbers, prime and even numbers in 10 to 20, so prime numbers 11, 13, and 17, 19 are prime numbers, and 12, 14, 16, and 18 are even numbers in between 10 to 20. So clearly there is no intersection between these two events, which means that they do not occur simultaneously, or they are mutually exclusive events. So event E or event F occur in 4 plus 4 ways, which is 8 ways. As a remark, the sum rule, or in terms of set, can be defined in such a way. Suppose that event E and F are disjoint sets. Disjoint means that they do not occur simultaneously, or they are mutually exclusive events. Then the sum rule can be written as the number of events in E or F is equal to the number of events occurrence of event E plus the number of events occurrence of event F. So this is as set theory. The other concept is a product rule. Product rule, or we call it multiplication rule, and it's defined as suppose that the first event occur in n ways and the second event F occur in m ways. then the combination of the two events can occur in m times n ways, given that the two events are independent events. Independent mean that two events are said to be independent if the occurrence of the first event, the one event, does not affect the occurrence of the other event. So one event, when one event is happening, then it doesn't affect the happening of the other event, second, the coming event. So if in such a way that given that the event E occur in n ways and event F occur in n ways, then the combination of the two events occur in m times n ways. So for example, how many ID number can registrar of University of Content can obtain if the ID contains two letters followed by three digits? So how many register ID number can be prepared if the first two digits, the first two places are letters and the other three numbers, the places are digits. So each in English alphabet there are 26 letters, and in mathematics there are 10 digits, 0 to 9. So the first two digits are clearly covered by the first two places are covered by digits, letters, which is 26 times 26, and the other three places will be covered by the numbers. So 10, 10, 10. So when we multiply this one, we'll get this one 676,000 different ID numbers can be prepared. Another example, how many even integers with distinct digits are there between 1 to 99 if we write integers between 1 to 99 in the form of 01, 02, 09? So how many even integers which with distinct digits are there between 1 to 99, assuming that those numbers in between 0 and 1 to 9 are written in such a way, 01, 02 up to 09. So here, let's take that A be the task of choosing a unit digit and from among five possible numbers. Well, so the question is distinct even integers. So two digits. So two digits mean that it has one place and tens place. So let's first choose the first place, the unit digit, or the unit digit. So in such a case, we have in such a case we have two digits. The first place is this one. So to make it even, the first if the first place, the unit digit, is an even number, then the number is even. So 0 up to 4, 0 to 4 and 6, 8 are even numbers. So how many possibilities we have? 1, 2, 3, 4, 5 possibilities. We have in the first unit we have 5 possibilities. So we have 5 possibilities. Now when you choose here, f, let's take another task for the tens digit. Let f be task of choosing tens digit. So there are 9 ways to perform the second task, since we can choose any one of the tens digit 0 to 9 except the one that was chosen for the unit digit, except for the one that was chosen for the first digit. So so we have 9 possible ways. We have 9 possible ways to choose in the tens place, in the tens digits. Therefore, 9 times 5 will be 45 ways of we have even integers in between 1 to 99, 1 to 99. So on the next class, we will see about permutation and combinations. For today, it's enough. Please like, share, comment, and on the video lectures.